Good day, everyone. So, this is a video recording of the solution for activity number 12 for Math 9. Solve the following and encircle your final answers. Show your solution in separate sheets. Please attach upon submission. So, number 1, problem is read as the difference of two positive numbers is 7. If the product of these two numbers is 98, find the numbers. So whenever you are answering a word problem, to see for look for the Q words. So the difference, that means we have to subtract the two numbers, right? Our numbers are positive numbers, okay? Two positive numbers. Whenever you see the word is, that means um, that's the equal sign. So the number followed by is, or a number before is, or the word is your answer to the equation. Okay, so therefore, if you let x as your first number and y as your second number, so their difference is 7. And if we multiply them, since it says that if the product of these two numbers, so multiply x times y, is, again the word is there, so equal sign is 98, then you are asked to find the numbers. So you are asked to find x and y. So let's put this in our whiteboard, in our blackboard rather. So our solution for number 1, we let our first number and second number, x and y, right, be the numbers, or positive numbers. Okay, so we are looking now for x and y. So the first equation, we have x minus y is 7, and that will be our first equation. And our second equation would be x times y is 98. That's our second equation. So to move on to our solution, right, to solve, so our solution is here. So from equation number 1, we isolate x, meaning you have to transpose minus y to the other side, that becomes positive, and your 7, so that will be y plus 7 equals x. So this came from equation number 1. Then afterwards, you have to substitute x with this on the equation number 2, which is xy is equal to 98. So your x becomes y plus 7, which is the x we just derived. Right, this have been substituted for x, and then the one that we already have is your y equals to 98, is equal to 98. That means this one is your the this is the equation 2. Your x times y is equal to 98. However, you had substituted that with this value, which is derived from equation number 1. Okay, so you have this equation being combined, two equations combined. All right, so from here you have to distribute y to the binomial. All right, we have y squared, and then we have plus 7y, and is equal to 98. Your new equation therefore will be y squared plus 7y minus 98, because we have to transpose positive 98 to the left side, then becomes minus 98. And this is now your quadratic equation. So we come up with a quadratic equation. So it's time to apply what we have learned from our previous discussion, solving quadratic equation. Now this is a trinomial, quadratic trinomial, which is factorable. Using our double bubble or our trial and error method, you have to think of a number or think of a factor of 98 that will yield to positive 7. When you add, that's positive 7. So that would be 14 and negative 7. So we have to add 14 here and we have to minus or subtract 7 here. So that is our factored form. So the expanded form is this one, which is equivalent to its factored form, which is this one. So we can apply the zero factor theorem, equating this factor here or the binomial here to 0 and equating this binomial to 0. So we have y is equal to negative 14 and the other answer is y is equal to positive 7. So since the statement or the problem states that the the y or the numbers that we're looking for are positive numbers, so we will disregard this one. So we stick with the value y is equal to 7, which is your y, which is your first integer, okay? The second integer rather. Okay, so if you're looking for the x, you um, uh, so yep, if you're looking for x, so that must be greater than 7, because we see that the difference between the two numbers x minus y is positive 7. So if you just apply or substitute y to the original equation that we obtained from the problem, which is x minus y is equal to 7, applying substituting the y, that will be x minus 7 is equal to 7, and then transposing minus 7 to the other side, that becomes positive, so your x would be 14. So your final answer would be 14 and 7. So the numbers that we're looking for are 14 and 7. So to check if it's correct, then it says that uh, the difference of the two numbers is equal to 7. So we subtract it, that's 7. And the product of the two is equal to 98. So therefore, the numbers that we're looking for in number 1 is 14 and 7. Now let's solve for number 2. Problem number 2 states that the sum of the squares of two consecutive positive integers is 25. Find the numbers. So keywords are sum of squares of two consecutive positive integers. Then we have the word is, which means equals. We have the 25. We have 25, right? So we let x be our first number and followed by x plus 1 be the second number, since they are consecutive positive integers. Okay, so let's go to our blackboard. Number 2 solution. Again, let x be the first number and x plus 1 be the second number. Okay, so the first sentence or the first sentence says that the sum of the squares of two consecutive numbers is 25. The sum of the squares, so we have to square first the first number added to the square of the second number, which is x plus 1 quantity squared, is equal to 25. So this is our equation here, and we are to solve for x. We are looking for that first number, and afterwards we're looking for the second number. So our solution will be like this. Okay, again, our equation is x squared plus the quantity x plus 1 squared is equal to 25. So, expanding this one, so we have to copy this first, and expanding this one, we have to square the binomial. That's square of the first term, the product of the first and the second times 2, that's 2x, and the square of the second term, which will be your last term, is equal to 25, that as is, right? So here we have to combine like terms. X squared and x squared are like terms. Also, we have to transpose 25 to the other side. Now, your new equation will be 2x squared plus 2x minus 24, because we will have a negative 25 plus 1 equal to 0. Now, we have a common factor, so we can reduce our quadratic equation. We obtain a quadratic equation, but we can reduce it so that we can solve it easily. Dividing the equation by 2, dividing both sides of the equation by 2, you will get what, x squared plus x minus 12 is equal to 0. Okay, now again, rewriting the equation, I have x squared um, plus x okay, x squared plus x minus 12 is equal to 0. So by trial and error method or double bubble, you have to factor the expanded form, the quadratic trinomial. So the factors of x squared are x's separated. Factors of negative 12 that will yield to positive 1 are 4, positive 4, and negative 3. Okay, zero factor theorem, our first value would be x is equal to negative 4. Second value is equal to positive 3. Now, it is stated in the problem that the numbers that we're looking for are positive. Okay, so we will stick with our positive answer, x is equal to 3. And looking for the consecutive, or since we are looking for the consecutive numbers, so our next number after 3 would be 4. So therefore, numbers that we're looking for are 3 and 4. All right, so going back to the problem just to check. So since they are consecutive, so that meets the criteria. They are consecutive. They are positive, all right? They are integers, and at the same time, um, this the sum of their squares is equal to 25. So if you square 3, that is 9. If you square 4, that is 16, and their sum is 25. Okay, let's move on to the next. Number 3, where it does. A rectangular room has seats arranged in M rows and 36 minus M columns. If the total number of seats is 320, what is M? Okay, so we have a rectangular room and the seats are arranged in rows and column. So here, like for example, I have a seat here. Okay, let's for example, let's I RC uh, mhm. Okay, going back to our example number problem number 3. So the room is arranged in one moment. Okay, m rows and 36 minus m columns. So if you have a room like this, these are your seats. So these are in columns, and these one example, the dots are the seats. Okay, if you want to count the number of seats, what you're going to do is multiply the number of the columns and the number of the rows, or vice versa. Okay, so it is stated on the problem that the total number of seats is 330. So we can just multiply m and 36 minus m and equate it to 320, because that's the way we count the number of seats. All right, so going to the blackboard this time, problem number 3. Okay, so we have m times 36 minus m, which is your column, is equal to 320. Okay, and for your solution, you just want to multiply um, the variable m to the binomial 36 minus m. Okay, and get a quadratic equation. So multiplying this will get a uh, will get 36m minus m squared is equal to 320. All right, arranging it in order in such a way that your leading coefficient is positive. So we just transpose everything to the right first. So that becomes 0 is equal to m squared. We have negative 36m, and we have plus 320. Okay, flipping the the equation, putting your right expression to the left side of the equation, and the 0 to the right, we will get m squared minus 36m plus 320 is equal to 0. Okay, or as reflexive property can do the same. All right, so we have a quadratic equation. Let me copy it again here. So we have m squared minus 36m plus 320 is equal to 0. So double bubble, make a bubbles like this one, equate it to 0. Factors of m are m and m. Factors of 320 that will yield to negative 36 are negative 20 and negative 16. So both negative, negative 20 and negative 16. Using the zero factor theorem, equate both to 0. You will get m sub 1 is equal to positive 20 and m sub 2 is equal to 16. So taking note that they are both positive, so they could be they could be, though they are accepted as your answers. There you go. So you have m is equal to 20 and m is equal to 16. Because if you have m, since we are to find m, so those are our answer. Because if you want to uh, if you wish to have m as 20, then that will be the number of rows. 20 would be the number of rows, and your number of column would be 36 minus 20, which is 16. So that could be the arrangement of your room. But if you choose m as 16, that would be the number of rows, and then 36 minus m, which is 36 minus um, 36 minus 20, rather 36 minus 16 is 20. So this also could be an arrangement. There are two ways we can arrange the room. Okay, so 20 rows, 16 columns, or 16 rows, 20 columns. So they are both accepted this time. Okay, so that's the final answer. Number 4, move to problem number 4, says that the sum of a positive integer and its square is 90. Find the integer. So we let the integer as x, and it says that the sum of x and x squared, or its square, right, is 90. So we have our equation. So let's just put it on our blackboard. So we have number 4. Okay, let x be our integer. The number, or the integer. Okay, so our equation would be x, and x squared is equal to 90. So this our solution is just go with this equation and solve for the value of x, right? So solving this, that becomes, you just arrange it in standard order, a standard form. You have x squared plus x, and then transpose 90 to the left side of the equation, we'll get negative 90 is equal to 0. I'll just recopy it so we can have space. X squared plus x minus 90 is equal to 0. Again, this quadratic trinomial is factorable. So the factored form is x and x. And what are the factors of 90 that will yield to positive 1? So that would be positive 10 and negative 9. So positive 10 times negative 9 is negative 90. Positive 10 plus negative 9 is positive 1. Okay, so equating the factors to 0. So you have x sub 1 as negative 10. Then we have x sub 2 is positive 9. So it is stated in a problem that what we're looking for is a positive integer. So we're good with x is equal to 9. So we disregard this one. Again, this one is not an extraneous root. It's a root of the quadratic equation. It's not an extraneous root, because if you substitute it here, you will he will satisfy it will satisfy the equation. It is not an extraneous root. However, we cannot consider it as our answer because it's stated in the word problem that our answer should be a positive integer. Next, number 5. So the problem is the sum. Okay, the sum of the two integers is 12. Again, we see the word is, so that is equal to 12. So we see the word sum, and since there are two integers, we can denote the first integer as x and the second integer as y. So we add them, equate it to 12 rather. So that's our first equation. Then you are asked to find those numbers if the sum of your squares is 74. So another equation would be the sum of your squares, x squared plus y squared is equal to 74. Since we have two equations and two unknown, we can solve for the variables. Okay, let's put it in our blackboard this time. Number 5. Okay, so again, let x and y be our numbers. Okay, then it says that x plus y is equal to 12. That's our equation number 1. Our equation number 2 would be x squared plus y squared is equal to 74. Equation number 2. Okay, solution. So our solution here. Okay, so from equation number 1, transpose y to the other side. So to isolate x, so we will have 12 minus y. And substituting this value to our equation number 2, which is x squared. So this time it becomes 12 minus y squared. That's the value of x. And then your y as is, y squared as is, and equal to 74 as is. Okay, so this equation that we have here is the combination of the two equations, equation 1 and 2. Okay, so now we expand this one. It's the square of the first term, which is 144. Then the middle term is the product of the first and second term times 2. That's negative 24y. And then the square of the second term would be y squared. Then as we copy the rest in the equation. So we combine like terms. So we have y squared, y square, and y square is 2y. Transposing it to the other side, we will have negative 74. So 144 minus 74, that will be 70. Okay, a new equation therefore would be 2y squared. We have positive negative 24 rather. That's y, our middle term, and a positive 70. 144 minus 74 is 70, equated to 0. Now, notice that we can reduce the equation by dividing both sides of the equation by 2 so that it will be simplified, or the leading coefficient becomes 1. So dividing by 2, we will get y squared minus 12y plus 35. In this way, we can perform trial and error very easy. Okay, so what are the factors of 35 that will yield to negative 12? So both are negative here. So we'll have negative 7 and then negative 5, because negative 7 times negative 5 is positive 35, and their sum is negative 12. So zero factor theorem, y sub 1 is positive 7 and y sub 2 is positive 5. So you could choose one of the value because they are both positive and they um, pass the criteria of the given in a word problem. So we can choose y is equal to 7. If y is equal to 7, then our x would be coming from the equation x plus y is equal to 12, substituting y. So x plus 7 is equal to uh, yes, equal to 12. So x would be uh, positive 5. Okay, so therefore our answers are um, 5 and 7. Or if you choose y as 5, then it will give you x is equal to 7. So you will still have the same pair of answers. So x, your final answer are 5 and 7. You want to check if that's correct. So the sum of uh, 5 and 7 is 12. So that satisfies the first equation. And the sum of their squares is equal to 74. 25 plus 49 is 74. So that satisfies the second equation. Now, for the last item, the problem is read as the difference of two negative integers is 8 and the product is positive or is 48. Find the two integers. Now, take note that the numbers that we're looking for are negative integers, two negative integers, wherein their difference is equal to 8 and their product is equal to positive 48. Makes sense because if you multiply two negative numbers, you will get positive answer. So let's just um, we let the first number as x and the second number as y. So the difference of x and y is 8. That's our first equation. Second equation is their product is 48, positive 48. That's our second equation. Put it on our blackboard this time. So item number 6. So again, let x and y be the numbers. All right. So our equation 1 is x plus, rather x minus, the difference of 2 is positive 8. And the product is 48. Right? This is equation number 1 and equation number 2. So our solution, okay, our solution from equation number 1, x is equal to, since minus x minus y, so it will become positive x plus, x is equal to y plus 8. That's from equation 1. Since substituting this one to our equation number 2, our x now would be x plus 8 and as is y as is, and then equated to 48. So this is our new equation coming from the two given or obtained equations, equation 1 and 2. So from here we can find y because it's only one equation and one variable. So expanding this or distributing y to the binomial, we'll get y squared plus 8y. Transposing 48 to the left side, we'll get negative 48 equal to 0. It's a quadratic equation, and that's a quadratic trinomial that can be factored perfectly. All right, what are the factors of negative 48 that will yield to 8, or the sum is 8? So that could be positive 12 and negative 4. So our factors are y, our quantity y plus 12 times quantity y minus 4. Checking it, that's 12 times negative 4 is negative 48. Their sum is positive 8. Our zero factor theorem, our first value is y is equal to negative 12. Our second value is equal to y is equal to 4. Now, since we are looking for a negative answer, since it's stated in the problem, so we will disregard y is equal to 4. So we will stick with y is equal to negative 12. So therefore, our y, our first number is negative 12. Our second number, which is x, can be obtained from the equation x minus 12. X minus y is equal to 8. So substituting negative 12 to this equation, we will have x minus negative 12 is equal to 8. This is minus minus, so that's plus. X plus 12 is equal to 8. Then so for value of x, transpose 12 to the other side, we get negative 4. Right? So our answers are negative 12 and negative 4. Okay? So the numbers that we're looking for are negative 12 and negative 4. That's it, guys. Thank you.